Okay, thank you. Can everyone hear me? Okay, seems loud in my head, but it's always good to check. Yeah, so as you mentioned, I'm Elizabeth Wehner. I work at BuzzFeed out of the Minneapolis office, which is one of our smaller offices. We have about 35 of us there, pretty much all in tech. We have one video person who's our creative, who makes us all feel slightly cooler. And yeah, today I'm going to talk about an experience that I had working, writing a new service to interface with a new Twitter API that we talked them into building for us. So that was handy. Okay, so the problem that we were having, a little background, for us, and especially in the news division, keeping information up to date is really critical. We have to keep it up to date on our own system. That's obviously one important part of how that works. But an additional challenge is that for much of BuzzFeed content, it's located on other systems, or it's consumed on other platforms, like Facebook, Snapchat. And even if people aren't reading it on those platforms, like they've probably followed a link from social media back to our owned and operated site. So keeping the metadata fresh for posts, for people sharing things, is really important. For some people, it may be the only way they see our post and decide to click on it. So if it's out of date, that could be a problem. And yeah, again, especially for the news team. So we need other companies sometimes. We have to rely on other people to refresh our metadata for us because it's not on our site, it's on theirs. Places like Facebook and Twitter, and we don't necessarily have control over that. So when an editor publishes a post, the main way to create and edit their content is to use our home-built content management system. So that's what this looks like for the editors. Has anyone here made a BuzzFeed post before? Okay, there's also a community version of this. It's very similar. If you're an editor, you just get more options in that sidebar there, that things you can do that community members can't do. And you can see they can choose what kind of post they want to make, upload thumbnails for it, set the titles, background. And then another thing that's really nicely configurable is there's this button here that says Preview Social Sharing. And so they can even set the specific details of how exactly we want it to look if you share it in Facebook or you share it in Twitter. So say you have something very important that's about to happen. Maybe that's an election, maybe it's a sporting event like the World Cup or the Olympics. You'll often see editors using titles leading up to that event that are anticipatory. Olympics is about to start, or so-and-so is leading in the election. And if you're a news person, you're probably often using that for like a breaking post that is constantly updated as the event unfolds. So yeah, you might put a picture of the team you expect to win or whatever. The editor then publishes that, and that information goes to the site. This is just me testing, so if you go to my BuzzFeed account, you'll see a lot of really exciting posts like this. There's also test, 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 and blurg, blarg. I'm a very prolific writer when it comes to BuzzFeed posts. But these titles and images can be very carefully curated and set by the editors. So, as you probably know, but just in case, this relates to, like, if you go and share this link on Twitter and you paste the link in and then you hit share, it will autofill this information. So it will grab the picture, it will grab the title and the description, and it sticks it all in there. And then that's what users see when they go to your feed and they're scrolling through and they're like, oh, maybe that's cool, I want to click on that, or maybe I don't. And so yeah, that's often, like in a sense, you can think of it as wanting a good first impression. You want that to be up to date. So because we want people to read our stuff. However, as events unfold, these data often need to be updated. Maybe an unexpected candidate won the election. Not that that ever happens. Too soon, sorry. Maybe the underdog sports team won that no one was expecting, so you're going to change the picture and change the title. And you want to make sure that that new headline information, it's all updated. So you can even update the data on how you want it to be shared. So you could change this. Every once in a while, we'll need to change it because we've decided that maybe it wasn't a wise choice of a title, like, or there's, there's a lot of reasons why you might want this to change. So you can say, okay, go in here, fix it. Instead of saying very important news is about to happen and we're expecting outcome A, now it will say very important news has happened and we want a new share text. So it happened. It's super important and outcome B happened and everyone is surprised. So now we really need our post to say that. So when a change is published by an editor, a notification is sent out from that system, and then various things will be triggered to happen on our end. So one very important one is that it sends out a request to purge the cache. So basically the way it works is if you go and hit this article on the BuzzFeed site, if you're the very first person who does that after someone presses publish, the cache, in our case, we use Fastly CDN, will get a version of it, cache it for us, and then it will just serve that out. So the next people that come looking for that post will just get it from Fastly and not from us. But that means that we need to get Fastly to have the new information if we make a change. So we have what we call queue readers that listen for changes, and then if they detect one, they say, okay, Fastly, please forget everything you know about this post, go get a fresh one. And then the next time someone hits that site after the cache is purged, it'll build a new copy for them, give it to them, and then start giving it to everybody else as well. So that's pretty handy. And the next thing that will happen is once the cache is purged, we have another queue reader that I also built to send out a request to Facebook to say, hey, we got some new stuff. Please pull it in, take our new metadata and use that instead. So that was cool, and that pretty much responds right away, happens immediately. Twitter, on the other hand, did not work very well. Like unfortunately, there was no option at the time. Twitter actually gets new metadata by using like a robot crawler that just crawls through their content every 7 days. So you might go to Twitter and share this, and it'll still say very important news is about to happen. So that's not good. They're still predicting outcome A will happen, but we know that outcome B actually happened, and that's just, it gets embarrassing, especially if you're the news team and this is a super important thing and you want people to take you seriously. You don't want old and embarrassing headlines to make you seem like you don't know what you're talking about. So yeah, that was a problem. Our news team in particular was pretty unhappy about it. Yeah, and old data could persist for up to a week. It's just really long in a news cycle, like epically long. Yeah, so what to do? For a long time, there was no option at all. Twitter did not offer a way to request a rescrape on demand. So we asked them if they could build it for us. And it did take a fair bit of nagging, perhaps. I get the impression there was like 6 months of back and forth on that. We may or may not have deployed Facebook does it for us. Um, you could do it too. And after about 6 months, they sent us information about a shiny new endpoint that we could use. So that was super cool. Okay, so before I go into the QReader details and the problem I tried to solve, just want to kind of go over a little bit about, a little digression about QReaders in general and how we use them at BuzzFeed. It's a very short digression. But basically, we use NSQ, which is basically a big messaging system. And it helps systems that are otherwise unrelated to communicate with each other and thus coordinate efforts. So for us, we have our content management system, which is the post creation tool. And when it's an update is published, it sends a message out to NSQ and says, hey, purge the cache, do it. NSQ will pass that message along to anything listening in that channel. And so we have this QReader here that is listening to that. This is an ear in case you can't tell. It's kind of not super high res. Anyway, so then this QReader will say, oh, hey, it's time to purge the cache. Cool, we can do that. And then it will go and do that. And then it sends a message back to NSQ that says, I did it, yay, we're all done. NSQ will then take that message and broadcast it on a channel for anyone who's listening on that channel and say, hey, it was purged, pay attention. And then this is the QReader I'm going to talk about building. The Twitter scraper needs to listen to that and then respond by sending the API request to Twitter and say, please rescrape. And then hopefully Twitter will say, okay. So some random things about NSQ in case that's a new thing for you. It's really just a central hub for receiving and sending out messages. It doesn't really have any, investment in what those messages are. It will just, it's just a delivery service. I have not worked at other companies in tech. I was a professor before I was at BuzzFeed, so I don't know, maybe everyone calls them QReaders, but maybe that's just a BuzzFeed thing too. I don't know. Anyway, we call them QReaders, I think because of kind of an abbreviation from that. So it's also noteworthy to understand that NSQ will just keep trying to deliver your message. There's sort of a built-in default for how many times it will try before it gives up. But if you want it to stop trying to send you a message, you need to say, hey, I'm finished with that message. I got it. Thanks. So you need to explicitly tell it that. And you can configure how many times you want it to try and how long to wait between attempts, things like that. Sometimes you'll want to even create random staggered reattempts because you don't want to have say it relies on an API call and that system is down, then a whole bunch of things will fail at the same time and keep getting requeued at the same time and keep hitting that system too hard and it'll just propagate. So staggering it out can be handy too. And yeah, it's really, really good for getting different systems to hear things about the other and respond. Okay, so we've had a QReader in place to listen for article publish events for a while now. And this is the one that also ends up triggering the Facebook rescrape. But we need a new service to do this for Twitter. And it turned out that the Twitter one is a little more complicated than the Facebook one. So this is the Twitter that the QReader that I built. Named as such because it responds to CDN purge events and it sends information off to Twitter. And so it's going to just listen out for any time the cache was successfully purged. If it didn't successfully purge, we don't want to rescrape the data. That's not any use to us. So only if it's successful, then we want to know about it. That first QReader that actually goes and purges the cache when it's finished, it will send this outbound message, which becomes the incoming message for the second queue reader. And it just contains information about the source, what service sent it, the type of event that is happening. It needs some kind of session ID, which you can just stick something in there. And then for this Fastly ID, that is actually a combination of some, I think, 4 letters out front, and then it's the numerical ID for us of what our post ID is. So it knows which one to scrape. And then this is, again, an internal service that initiated the initial request for the purge. So once it gets that message, it needs to respond by asking Twitter to purge its stash metadata and get the new stuff. So in general, the anatomy of a scraper looks something like this. You have the main function, which does some setup for if we're in debug mode. We want it to restart anytime we change something in the Python. Don't need that if you're not in a dev environment. We set up some logging, because that's handy. And the main thing it really does is set up your queue reader and then run it. So the things you need to set up the queue reader, you need to specify a message handler. That's just saying, okay, a message has come in. What do I do with it? Let's call the message handler and send it off to that. So that's the name of the function that will handle it. This is some internal settings on where to communicate on our network stuff. And then we need to tell it what topic and channel you want to listen to. So the NSQ is sending tons and tons of messages all the time. You don't want to overwhelm your queue reader by having it have to listen to all of them. So you need to set some specifics. So in this case, we're listening to the NSQ topic and channel happen to be called the same thing, which is just CDN purge events. So we want, if there's a purge event of any kind, we want to listen. So yeah, the main thing is going to be the message handler, which will then call the rescrape Twitter. When I named this, I didn't think about having to say it well at the talk. It's a little tongue twister, I guess. And so we want to rescrape Twitter. We want to send it our buzz ID. We call our articles buzzes. And then that way, like as engineers, we don't have to care whether it's an article or a list post or news or whatever. So everything's a buzz. And then it needs to receive the message as well. And just as a side note, it will call this. That's just how we get the specifics about that buzz. So its title, its URL, its author, all its details. Okay, so one of the first things that we do at the top is say buzz equals get buzz. And we have to pass that buzz ID and a message. And then it will go off and try to get that information from our own internal API system. If it's successful in doing that and it returns an actual buzz, then we're good to go. We want to put together the URL. We tend to just store the canonical path, which is the author name / title, rather than storing the whole URL. So we build that up. We also want to check the post status. I'll show you why later. That was added after the fact. But we want to check whether it's a live post or it's a draft post. And then we only want to proceed if the post is live. So if the post status is live and we have a URL, let's log that we're going to do this. And then here's where the magic occurs, where we build and make the API call. We're going to go into detail on that in a second. And then, assuming that works, we get our result code. All looks good. We keep track of metrics so we can see how often it succeeded, how long the API call took, all these things. We log it out that it was successful for that buzz ID. And then we also log, we need to tell NSQ that we finished with the message. So it will stop trying, because otherwise it will just keep going, hey, 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 I have this message for you. If it's not successful, we try to pull the error out of the response, log it, and the metrics will record the reason that it failed. We can re-queue the message. And I give it a little delay. Yeah, so, and then if it's not a live post, it will just say it's a draft, so we're not going to scrape it. Oh, the async. Yes, so what we want to be able to do is to make an asynchronous call so that we can do multiple ones at the time, all the time. That didn't come out well. We don't have any way that's already built managed for us. So that would have been an option to try to batch it and send it off at the same time. But we also, basically, we were doing this anytime a post is updated anywhere, whether you're a community member or whether you're part of the news team. If you make an update to a published post, it will rescrape everything for you. And it creates a bit more traffic, but that's how we prefer it, just because we would rather everything stay as current as possible. That's a priority for us. And so, yeah, there's actually a lot of requests coming in at the same time, and so we want it to be, each request to not be blocking. Otherwise, you can get a rising queue depth. Well, you can get that anyway if something else is going wrong, but basically you just don't want them piling up if there's a lot. So they need to be asynchronous. That was one of the requirements in the end. Okay, so the refresh endpoint, it's in beta at the moment, meaning you need to be whitelisted to have your app use it. It's listed there. And there were a number of requirements. One is that it needed to be a post request. That just came from their end on Twitter. It requires authorization and parameters. The parameter weight is optional, but weight will be an asynchronous thing, so you only get the response. You will get a response once it has succeeded. Otherwise, it's like a fire and forget if you put weight as false, and it will just say, okay, go do it, and then I'm not going to keep track of whether or not you did it. So we wanted to wait for that. And then the required URL. It also requires custom header information, which is just content type application, JSON. So yeah, I should say I've been writing Python code off and on, because I do full stack, so every once in a while I'm doing JavaScript stuff, and only for a couple years. So it is possible that someone doing this longer would be able to find a different or maybe even more expeditious solution. But I kind of just wanted to walk through my process of exploring these things. So they recommended using twirl. This part at the top is a quote from them. We recommend using twirl if possible, as it handles the authentication for you, which is great. And they gave a sample call for it. And they're not wrong. I tried it. I got it set up and working. They're right. The authentication was great. However, it was difficult to fit into, this is a Ruby gem. It's a command line interface. We have kind of a very specific way of managing our secrets, our auth information. And between that and getting this to be async, I just couldn't find a way forward. I was looking at Python versions of twirl library. They are out there. I just couldn't find a solution to those problems that would make it work in a QReader format. What's that? Yeah, that would be he said a ton of background jobs in a shell script. I'm like, that would probably work, and I think that might be what Twitter was imagining. this was our first indication that Twitter maybe did not understand the fire hose of information we were about to start throwing at them. It became an issue. So I cross this off as a possibility. Okay, if you use Python, you're probably familiar with the requests library. It's awesome. It's here. It was my next go-to. And they advertise it's HTTP for humans. It's very common sense and user-friendly. I like that. And so I looked at this next, and it handles the auth. Great. That's good. We can work with that. It allowed for the customizable header info, which was required and nice. It's not asynchronous, though. It is a blocking request. And so we want to be able to spin off, say, 300 requests at the same time and not have to wait for one to finish before we move on to the next one. So this was kind of a problem. So I don't know. I was reluctant to rule it out. So I continued looking and moved on, but I couldn't bring myself to make an X on there. So the next thing I looked at was the Python Twitter API library, which is here. It handled the auth, great. Async, sort of. There was no function in there to do what I wanted to do. So the question was, because nothing uses this endpoint, we need to be able to send the specific endpoint information. We need to be able to send auth data. We need to be able to do the customized header information. And so the question was, could I co-opt another function that was kind of meant for something else and use it for what I wanted to do? And again, I couldn't find a way to do both of these things together. Well, without modifying the library. And that would be a possibility, but I was trying to find the most expedited way forward, and I decided that was probably not it. So I was very meh on this. Didn't work out. I spent a lot of time staring at that source code and going, okay, I don't think it's going to work. So in the end, the final solution, I did end up using requests, and I built it into a surrounding asynchronous structure, which was kind of fun. The advantages were that we can use OAuth to build our credentials. It handles post requests very nicely. Custom headers are easy. It's a good library. It's very reliable, and that's been proven. Again, we've been using it for months now, and it's very stable. And it turned out I was able to figure out some Python tricks. Well, to me, they seem like tricks. Using a blocking function within an asynchronous environment. And that looks something like this. So this first part is just building up the request, pulling in our auth settings. The payload that we want to send is just the URL. Weight defaults to true, so we didn't need to send that in the end. Sending the header information and the endpoint information. Okay, so I'm going to skip this and come back to it in a minute. So here's the actual API call. And again, we're using a metrics timer to be able to measure how long the call takes. We set up an event loop, and then using that loop, using the run and executor function, which I had never used before. I have done like fire and forget types things and other basic event loop stuff. But run and executor, it turns out, is a good way to spin off an individual thread for what you can use as a blocking function. In order to do that, what it actually takes is a partial. And you can create the partial here. So here I just named it work. I think they do that in the documentation. That's why I called it work. I don't know. And so here's the function requests, requests.post. So you use the function, and then the data that basically you want to send to the function. And so instead of making the request here, you just send it all that information so that it can make the request. And then you send that into the executor loop. And so it will spin it off. And it can do that for 1,000 different messages at the same time. And each one is individually blocking. But They're not dependent on each other, so it works out really well. And oh yeah, so in the end, what you get is a future that you can then await. Okay. So we're done. It was, now it's updated immediately. It worked. We did have a brief moment with Twitter where we were getting a lot of 429s because the request denied from hitting our rate limit. But we were able to work with them, and that part of that was like cutting out drafts. We separated the live posts and the drafts, and that brought it down just enough that we don't really get 429s anymore. And you can also, I think this is fun because you can see like when the editors are working. It's like, anyway, that's the end. Thank you very much. I'm happy to answer. We don't have time for questions, so if you want to ask me anything, feel free to find me. In a few minutes, I'll probably migrate to the hall so the next person can set up here.